Okay, so good afternoon. So thanks for the introduction. As Chris was saying, my background's slightly unusual. I've come from the computer science department, did a PhD with Doug, and then worked as a joint role between our academic computer science department and our services department. So I've seen both sides of the fence, you might say. So it's always interesting to get the view from the services department about all the academics and their requirements. So I've seen both of those. So I've rather cheekily introduced yet another acronym, SDN, but a slightly different interpretation of that acronym, something different about networking. And I'm really excited about SDN and the developments around there, because for me as a networking researcher, I very often find that the network's expected. It's a utility service. People are not really that interested in it these days, and I say that as a hardcore network researcher. Everybody just assumes it works. Okay, it might get faster over the years, but it's just there. And everybody gets excited about cloud computing and big data and new exciting services, and they run on top of the network. But actually, what's interesting to me is how we can use the network and how we can really innovate with the network. And I think that's something that SDN will certainly offer, that ability to build and innovate within the network itself. So without further ado, I'll just introduce a little bit about what I'm going to talk about today. I'm going to talk from my perspective about how we're evolving the network, in particularly around cloud computing and network innovations based around SDN and NFV. I'll talk about some of the research that we've been doing at Lancaster in this area. I'll particularly focus on the ToCan project, which Matt asked me to talk about. That's a new UK-led project around SDN principles. And then I'll talk very briefly at the end about some other local work going on at Lancaster and a signpost to some presentation that I'll be giving at Net Workshop. Okay, so you'll commonly see these sorts of slides shown from various partners around statistics about growth, and obviously we've talked about IoT this morning, so we're expecting lots of devices to be connected to the internet in some way, 50 billion devices, I think Cisco predict by 2020. We're seeing developments in cloud computing and private and personal clouds, and particularly that's not just driven by cost reduction, but agility is becoming a key factor in that as well. And we're seeing an increased growth in this need for scale and programmability and control and management of that. And we can see forecasts around cloud and SDN, so IDC forecasts cloud computing to reach 73 billion by 2016 and SDN 8 billion by 2018. So these are big growth areas. From a network perspective and from a researcher's perspective, the challenges that I've faced for many years is actually how do you innovate within networks? We've got highly complex networks. Many functions are there baked in tin into the infrastructure, and we can do very little with them. We can't innovate. They're typically closed architectures. The lines are blurred between those systems. They're not often documented in terms of the innards of those systems. We find that they're vertically integrated, they're complex, closed, proprietary. It's difficult to innovate within that environment. And yet at the same time, we're seeing that networks, we have an increasing need to build networks with application awareness, with that awareness of what's happening, both at the application level and underlying the network. And we also are under pressure to deploy infrastructure and new services faster, more rapidly, and cheaper, of course, at the same time. And unfortunately, the environment we've been in hasn't made that easy to achieve. And certainly as a researcher, it's been very difficult to innovate. And I build networks and test beds, etc. It's very difficult to innovate within that environment. But we have something called SDN that's already been mentioned this morning. And this is kind of my take on that. We now see, and we've seen models in the mobile market with Apple and their iOS platform, and Google and Android, and models where when you build some services, you develop APIs, and you offer an environment where people can innovate, off they go. And it's interesting to see that sort of analogy now being applied to networks with this concept around SDN, so that if we have these open access SDN compliant hardware in the network, we have interfaces to that, and then we have a well-defined API, we can actually then build applications and services within the network, supporting the network. And I think that's really quite an interesting paradigm. And some of the principles of SDN, I won't go into too much detail around, but we're really looking at the fact that we've got intelligence, and the fact that we've got this centralized control really gives that intelligence within the network. So we have visibility of, say, for instance, all of the traffic patterns that we can then make intelligent decisions based around the behaviors that we're observing, and we can then have applications involved in informing those decisions. And so there's a range of characteristics, principles around SDN that I think some of these have already been talked about this morning, so I won't go into too much detail. But there's clear momentum behind using this to provide new services, reduce operational expenditure, simplify network operations, offer better monitoring and diagnosis, and particularly around a level of automation and abstraction. At the same time, we talked about SDN, we've also seen an emerging trend around NFV, or Network Functions Virtualization, around the more cloud computing activities. And this is actually not really a new, okay, it's talked about in the context of NFV, but the underlying concepts around NFV, which is around the virtualization of resources, are not new. What we're doing here is that we're actually taking software elements that would traditionally have been baked into hardware on an end device, so a particular router. And we're taking those out of the device and now putting it into a generic, say, an x86 cloud computing environment. So we're looking at taking away some of the challenges that we have with deploying network functions. You have all of the issues around putting in equipment, takes power and space, and you obviously need to have all the technical know-how to install it. You've also got the other factors that we're increasingly under pressure to put new services in rapidly, and the life cycles of technology are becoming much shorter. So by then taking out some of those network devices, or at least some of the functions that exist within those network devices, bringing them into software, bringing them into a generic cloud compute resource, we've actually got a lot of flexibility there. And that's the concepts around NFV that we're starting to now see emerge. This is relatively new. In the last year or so now, we're starting to see a lot of interest in this area. And you can clearly see why. If there's an opportunity to reduce your costs by using generic cloud compute resources than buying an expensive piece of hardware that sits in a corner somewhere, then clearly people will look to this. It also offers you potential to scale, because you don't have to worry about having bought that box 2 years ago and actually you've reached the lifetime in terms of its capability. If you move that functionality into a cloud compute environment, obviously you've got those scalability characteristics with cloud. So this is one of the concepts that we're starting to see emerge now, and we're very familiar with this concept. We've been doing it many years when we've talked about operating system virtualization and moving what used to be proprietary operating systems with services running there and putting them now into generic compute resources. So there's really a lot of interest in how we might use NFV to virtualize a whole class of different network functions, from firewalls, DPI, WAN accelerators. And I think what's really interesting is when you combine those SDN principles that we've talked about with NFV, you really then bring in this empowerment around automation and orchestration. And actually, I think orchestration is one of the key words from this. SDN and NFV combined gives you that ability to orchestrate services using centralized control. So I think that's, I'm not suggesting that's we're there yet with NFV, but it's clearly an emerging area, and it's something that I think is really exciting as a development. And it's with that in mind, of course, that there is a lot of hype around SDN and all these technologies, and I don't think, I think it says SDN gives you whiter teeth. I'm not clear that that's necessarily the case, but you have to be careful with these subjects, because there is a lot of hype around SDN. People like to invest in, hopefully, the technology rather than the hype, but I think it's certainly, for me as a network researcher, one of the most exciting developments in the networking sector for many years, and I'm really excited about being able to build on it. But there's a note of caution there. You have to be careful about the hype that surrounds any new areas such as this. Okay, so I'll talk a little bit more about what we've been doing at Lancaster in terms of the research around SDN. And I've been involved in SDN and a number of projects for about 3 years or so. One of the areas that we saw early on as a potential to exploit or leverage SDN is around video distribution. And I hopefully don't need to spend too much time motivating why we think video distribution is an important area to look at. When you look at all the projections for traffic growth, these are ones coming from Cisco. The projections are that internet video traffic will be about 79% of the global traffic in 2018, and actually, these scare me, these figures. The amount of VOD traffic by 2018 will be the equivalent of 6 billion DVDs per month. And similarly, you're seeing trends on the mobile sector as well. So mobile video consumption is also on the increase and growth there. And that growth around video obviously challenges the underlying infrastructure. And one of the things we've been looking at is how we can actually use SDN to perhaps relieve some of those challenges on the underlying infrastructure. So can we use concepts that are not new, the concepts of caching that we're familiar with, right the way from PC caching in RAM through to CDNs across internets to cache content? Well, can we use some of those caching concepts and apply it with video with SDN behind that? And one of the things we've been doing over the last couple of years is building a technology that we call Open Cache, and that's an open source caching platform that uses SDN. So it uses, in this case, it uses OpenFlow, and it uses OpenFlow mechanisms to allow flows to be redirected, and that's redirected for a range of reasons, but it may be based around load or availability of content. But the key thing is around redirection to more appropriate locations for content that's stored potentially closer to the end user. So we're looking at how we can use SDN to balance those requests and also provide live migration. Now, many of this has been done, or some of this has been done within the internet now with the concepts of CDN. But what we're really interested in is how SDN can do that. And actually the difference here is, as it says on the last line there, with SDN, it's actually the network itself that becomes this video cache. So the intelligence is now living within the network. And obviously the network has a much better visibility of traffic loads and traffic profiles, and actually having the capability to make those decisions when you use paradigms and architectures such as SDN. So this is one example, and we're still developing Open Cache, and we're looking to explore that further, particularly around the developments on NFV now. So we see this as one interesting application area, but there's many applications within the SDN world. We've been building our own SDN testbeds, and I'll touch on that at the very end of the presentation, but we've also been working on a number of research projects that have been deploying this video cache across Europe. We've been involved in, these are all European projects. Ophelia was actually one of the first OpenFlow SDN testbeds, started back in 2010, and we were involved in doing some experimentation on that infrastructure. Giant also, about just over a year ago, created their own SDN testbed across a number of sites in the Giant infrastructure, and we've also been participating with them in terms of evaluating their own SDN infrastructure for this type of application that we've built here. And Fed for Fire is another European project that's again built a large testbed, some of which is SDN capable, and we've been looking at how we support this notion of video caching across a number of different sites. Actually, in this case, not all of them have SDN, and so that's quite an interesting model where you may have this mixed environment there. So this is the work that we've been doing for the last 3 years or so. But I'll now come on to one of the new projects that we've just been launching called ToCan, and ToCan has only just started, just at the end of last year, and it's an EPSRC UK-funded project. It's a program grant project, so it's 5 years, so it's quite a substantial duration. It's with the University of Bristol, Heriot-Watt at Edinburgh, and the University of Edinburgh as well as Lancaster. So there's a number of academic partners in there. Bristol, particularly experts in the optical domain, and also have wireless experts there as well, and Harriet Watt at Edinburgh also with wireless as their focus. So what's interesting in this consortium is actually we're bringing together groups that have not necessarily worked together. We've got groups in optical, we've got groups from wireless, and actually we've got computer networking people as well, bringing together all of those flavors. So people that work at very low levels in fiber optics, optical, and wireless. And it's an interesting project. We're just learning the terminologies. We talk to each other in the recent meetings about actually things in one discipline, whether it's wireless and optical, or actually you can be talking about the same thing and it means something entirely different in those different communities. So it's really interesting to have a project that brings all of those together. And it's bringing those together because the objective of this activity is all about convergence of fiber, optical, wireless, and everything. So it's got quite an ambitious title towards the ultimate convergence of all networks. And it's really looking at trying to create a technology agnostic architecture for convergence, but it's based around SDN principles. So a lot of the work will be leveraging SDN activity. One of the key technology domains, well actually, I mean, we talked about Internet of Things, we've talked about the petabytes of data that are going to be pushed around networks, and actually one of the big challenges is that ToCan is designing at least a solution that supposedly accommodates all of this, and that's going to be a significant challenge, I think, in the next 5 years. So whether it's a small sensor with a very low bit rate of traffic, but then you've got millions of them, to large high-capacity optical networks, ToCan is addressing all of that area. So whether it's small capacity to large capacity, whether it's moving devices or static devices, ToCan's at least designing architectures that should be appropriate to this. It's a significant challenge. So the goals of the project are around this technology agnostic system, focusing on end-to-end optimization. So that's infrastructure and services. So not just the underlying network, but also potentially cloud compute type resources as well. And obviously we've talked about NFV, and naturally NFV and the concepts around that will be a core part of the sorts of services that we'll see within standard compute environments. The idea is that you can provide on-demand delivery across virtualized environments. So you can take this underlying infrastructure and then you can build a virtual level on top of that, which combines links and it combines services and cloud compute resources as well. And we're looking at various characteristics around optimization, whether that's capacity, connectivity, and spectrum. So these are characteristics that are really important, particularly to the wireless and on optic side, and bringing all of those characteristics together. Key innovations within the project, well, this is one of them, will be to try and build this converged physical infrastructure, and there's clearly key challenges there. We're at the moment thinking about, well, how do you describe what a device is and what characteristics it has, and how do you expose that to the upper levels? And obviously the various devices that you have may have to do aggregation, they may have to schedule, they have to think about traffic profiles and QoS, and we need to think about how do we expose that at the fundamental layer, so right down at the optical and wireless layers, and how we then bring that up the stack, as it were, if we're thinking about stack. So to try and give you some idea of what I'm referring to here, it's really thinking about the whole end-to-end service chain from users to data centers, and thinking about how we then abstract that into virtual networks and virtual infrastructures, and then build our own end-to-end services with service guarantees around that. The project split into a number of TCs, or technical challenges, rather like work packages. So we have TC0, which is around the architecture, to defining the architecture of the project. That's really where the key blueprint for ToCan will be developed. We then have 3 very much technology TCs, or work packages, that start very much from the bottom and work up. So at TC1, it's all about this level of programmability and control within the optical and wireless worlds. And how do you then expose that to TC2, which is built around SDN and software primitives? And how do we provide that level of abstraction so that we can actually have this unified resource abstraction that covers all of those domains, wireless and optical included? And then building on top of SDN, we look to have, and I talked about orchestration. Really what I would say is the orchestration layer on top of that. So how do you actually provide managed services? Think of infrastructure as a service as an example. Using virtual network functions, so using the concept of NFV and having functions that have been virtualized in a cloud compute resource environment. And how do you pull all that together and orchestrate that and think about applications that may have particular service requirements? They need to request those requirements from the underlying ToCan infrastructure. So very much TC3 sits at the top with applications building on that, right the way through to TC1 that's focused more around the fiber and optical and wireless worlds. And then we have another technical challenge around the lab, which is all around the experimentation, because we need to obviously build this infrastructure and experiment on this infrastructure, and that's where TC4 comes into play. And we'll be working with real-world users and user trials. And I should say there's a number of industrial partners in this project. We have British Telecom, we have NEC, we have Samsung, we also have Broadcom, particularly on the wireless side. So we'll be bringing all of those partners in to talk about use cases and ensuring that what we're building here is actually fit for the future requirements in those industries. I won't talk too much about the specifics around ToCan in terms of the individual layers, but this is how we organize the project. We have essentially these layers that I talked about, this service provisioning and orchestration layer. We have this concept of abstraction and virtualization, and then we have the technology specific parts, and then alongside we have the ToCan lab. And at the top we have the overall architecture for ToCan. So clearly this is going to be a challenging project. We've got lots of interest around how we actually build this infrastructure at an architectural level, how we address scalability, efficiency, how do we provide management, how do we provide interfaces to all of these different devices, where we do orchestrated service provisioning, how we interoperate with all of the emerging devices, but also support potentially legacy devices. So this is TC0, so this is more at the architectural level, and then at TC3, which I'm more closely involved with because this is work led at Lancaster. It's all around how we address some of the challenges around service deployment. So how do we address the fact that people are wanting services more rapidly, more sophisticated, more adaptable, with all the time that we obviously recognize that operators need to traditionally put in infrastructure and network elements that could take weeks of planning and engineering effort. How can we actually reduce that time? And also the growth in cloud and community and public cloud services. We need to be able to support the requests coming from that community and adapt the network to support. And as I say, the emergence of NFV, I think, is a key technology in this space to help us. So from a TC3 perspective, as I say, around orchestration, it's around the new platform to support the management of end-to-end services and all the architectural components. So we should be able to control and orchestrate these services and infrastructure. This is the sort of architecture diagram that we are focusing on at the moment, and as you can see, TC3 particularly is looking at user requirements, how these may be honoured, all of the elements that you may need to do in terms of automated provision, resource awareness, QoE, and then providing those down to TC2, which focuses on virtualization and abstraction, and then carrying on down below onto the wireless and optical sides. So it's a very ambitious project, lots of partners involved. We'll be building test beds across Janet. Janet's also working on an SDN test bed that we'll be using to interconnect Edinburgh, Lancaster and Bristol, and obviously there's other connections that are also available through the various light paths and the national dark fibre infrastructure. Each partner has its own test beds as well that it'll be bringing to ToCan. And ToCan is not doing this without an eye to industry and standardization. There's actually a lot of relevant standardization activities, particularly around ETSI and the IETF. I won't go into details, but obviously we'll make the slides available. So there's a number of IETF working groups where these activities on ToCan are directly relevant to activities that are ongoing and being developed at the moment. And actually some of the exciting new IETF initiatives are actually really key in terms of ToCan's activities for the next 5 years. A quick plug for NetWorkshop. I'll be talking at NetWorkshop around some of the other work that's going on at Lancaster. So I've focused this presentation on some of the research that's been going on, and particularly ToCan. Some of the other things we've been doing at Lancaster is actually building a production SDN infrastructure for researchers to use and working with our network services guys. And if you've ever worked with kind of network researchers and network services guys, you'll know that there's always great fun to be had there. And so this has taken probably about a year to actually fully deploy from purchase to realization. And so some of the NetWorkshop talk will be focusing on the challenges there of deploying things like OpenFlow within a production environment and the requirements from the network services guys that they have. And some of the other things that I'm also doing, I'll just do a quick headline to. I'm also working on thinking about how we introduce concepts around SDN into our curriculum at Lancaster. So if you have any interest around SDN courses or NFE courses, please come and have a chat offline, because I'm looking at growing activity at Lancaster to help kind of teach the next generation of networking graduates around some of these concepts. That's my time. Thank you very much.
Got time for maybe one question for Nick. Come on.
Is it possible to ask how this new world is embracing the concept of actually checking that you're allowed to do what you're requesting the network to do? So not only in terms of the data flows and information security, but also the actual, am I allowed to make these changes to the network?
It's a very good point, because I think we talk about all these possibilities with SDN, and I know from talking to our own network guys, I think there's a fear for that. Well, does this mean that any guy is just going to come along and be able to create new services? And I mean, certainly within the ToCan architecture, there's still the notion of some level of authority and awareness of what's going on, and some checking of those activities. But I think from a standardization perspective, I think there's still things that need to be developed there. But I think there's a lot of ambition, but I think it just has to be kind of reined in a little bit. And I think we don't necessarily have all the mechanisms to do that reining in. But I think that people are aware that that still needs to happen, if that answers your question.
And have they thought about concepts like federation and moonshots?
Exactly. Federation, multi-tenancy, all of those issues are ones that I wouldn't say are completely solved in the SDN community, absolutely, but again, there are areas that I think people are conscious that need to be developed. They're definitely active areas within a lot of the standardization community.
Okay, I think that's probably all we have time for, so can I ask that we thank Nick for his excellent.
Thank you.